Thank you. Good morning, good afternoon, and good evening for the people who are joining from EST, PST, and European time. Let's begin. So today's session is about how VMware IT is driving application modernization with Tanzu. I'm your host today. My name is Mukund, and along with me, I have a couple of team members. I will introduce them as we go ahead. Okay, so this is a standard disclaimer. I would request all of you to have a look at it. So in today's agenda, we will look at the VMware production environment overview, right? What is there and what's the scale of operation that we have that we are managing in VMware IT. We will look at how we are breaking down monolithic applications into microservices. Then we'll look at the CDTO modern application platform that we have built over the period of time. And then we will look at the DevSecOps story, right? So basically three personas we are going to cover today. That is the developer persona. Then we will cover the platform operations persona, and third one is the DevSecOps persona. Right? And at the end, we will also look at or take the Q&A at the end of the session. Okay, so let's begin. So before we start, we will have a quick round of introduction about the speakers. As I mentioned earlier, my name is Mukund Yadav. I am director in the VMware IT. Close to 10 years of experience in VMware IT and 25 years of industry experience managing in the fields of platforms and databases and platform and application platforms. So let me hand it over to Eric for his quick introduction.
Hi, everyone. So my name is Eric Wong. I'm a technical architect in VMware IT CTO organization. I have been with VMware IT for 10 years, working primarily on application platform architectures from technical perspective. Overall, I think I've been doing in this IT industry for about 23 years now, going from the mainframe programming all the way to modern technologies. So it's nice meeting everyone. Manas?
Thanks, Eric. Hello, everyone. My name is Manas, and I'm the manager for Modern Application Platform at VMware. I manage this platform for VMware, where some of the business critical applications run on this, and we'll talk about that in our presentation. Over to you, Mehul.
Thanks, Manas. Hello, everyone. My name is Mehul Patel. I manage and oversee all the strategy framework and operationalization of DevSecOps practices at VMware. Typically managing on a day-to-day basis, software-defined infrastructure provisioning, CI/CD platform enablement and automation, as well as application security functions. I have a background in design and development of applications, business applications, and that's where I leverage some of my knowledge to drive overall delivery for VMware IT.
Absolutely.
Over to you, Mukund.
Thank you. Thanks, Eric, Manas, and Mehul. Right, as I mentioned earlier, we are going to cover three basic personas. That is the developer persona, platform persona, right, and the DevSecOps persona. So all three experts are in this presentation today. Okay, so let's move on to the next slide. Right, so this is the VMware production environment overview. Right, the scale of operations is listed in various numbers here. Let me quickly go through some of the numbers. Right, so we have close to 24 data centers, and out of these 24 data centers, we predominantly use two major data centers, one in Santa Clara, one in Vinach. Right, those are the main data centers for the critical applications. But however, at each office locations and various other co-locations, we have smaller data centers as well to cater to the local office or regional applications. Right, then we have close to 7.4 thousand ASXA hosts, right, which are been used for various purposes for various applications, including R&D as well as the IT applications. When it comes to number of VMs which are getting created and destroyed on a weekly basis, it's like 1.6 million. And then the number of containers which are getting created and destroyed every week is 2.2 million, right? So A few years back, these numbers were reversed, right? So we had very less number of the containers which were getting created, but now that number has surpassed the VM, and we will see in the future slides how we are achieving this as well. And then there are various other numbers here on your screen. I don't want to go through each and every number, but in general, this footprint is serving thousands of you can say employees in VMware, as well as thousands of partners who are using these applications, and of course we have millions of customers who are using these applications which are hosted into this modern application platform. Okay, let's move to the next slide. The cloud native platform journey, right? So this is something that we have started in 2014 with the Docker POC, and then slowly we started looking at how we can utilize the Dockers for the non-critical workloads, and we started utilizing the third-party orchestration. As of course all of you know, right, we didn't had maturity in terms of Docker orchestration at that point of time, so we were solely relying on the third-party orchestration. Then we started building our CNA platforms, and Tanzu application service, that is the PCF platform, was introduced to all the developers. So all of you are aware, or some of you must, the flexibility of CF push and CF scale. So that was, you can say, very handy for our developers and useful for rolling out applications at a faster pace. Later point of time, we started also looking at various other new developments into the CNA platform, and we introduced the Tanzu Kubernetes grid, right, as we go along, and then we introduced the Harbor as a service. And Harbor as a service, we have provided two things. One is the internal developers within R&D as well as IT, how they can store and utilize the Harbor, right, internally. And of course we have also given it for a distribution Harbor, that is all the images that you can download from vmware.com are stored into this Harbor as a service internally. And then we have also done quite a good amount of self-service to our developers, so that whenever they want to start a new project or a new application, they don't need to open a ticket and stuff like that. So they can just simply go to a self-service portal, ask for an org into the task, or ask for a namespace into the TKG, or they can get a space into the Harbor so that they can start with their development. And lastly, so we are also enabling the hybrid and multi-cloud so that we can increase the availability of the applications from 99.9 to 99.99. So that whenever there is any outage into the data center, we are not solely dependent on the data center construct. We are making sure that these applications, critical applications, are available on the public cloud as well, right? So in that case, what we have also done is that to make sure that the application portability becomes very easy, we have come up with an standard or common platform, that is the TKG platform, wherein TKG platform is available for our developers into 2 data centers in VMware, which provides the high availability. Plus, we are also going to give the TKG on the AWS, so that application portability becomes easy, and we can also achieve the availability numbers as well. So this is the high-level timeline that we have gone through, right, from the 2014. And of course, this presentation that we are giving today, this will be very useful. You don't have to go through this journey from 2014 to 2022. So we can directly, you guys can directly hop on to 2022, right? What is available into the market, and what are the offerings from the VMware Tanzu portfolio that you can utilize. Okay, with this, let's go to the next slide. Next slide is about the developer persona. So we have Eric on the call. So Eric, all yours.
Sure. Yeah, Makong, yeah, this is good. Thanks, Makong. So we have gone through our history, that where we come from and where we are today. As you can see, that's a fairly long and the process. There's a lot of sweat and tears went into that process. So the question becomes is, why do we embark on that journey, and why do we doing it, right? So the purpose obviously is that as organization, VMware IT and the CTO organizations as a whole, the mission is to create, maintain, and run the application systems that power VMware as a business, right? So VMware as a business, its success depends on the capability of the CTO organization to deliver the critical business functionalities in the form of code and applications that can be leveraged by our business. So with that, our objective, obviously, along that journey is to be able to create things in production faster and also bring a higher level of quality. But with these two things, then we can help better empower our business to do what they need to do to improve and grow VMware as a company, right? As we go through this journey, what we learned is that with those objectives in mind, the best way to achieve this objective is to create smaller domain-based team and allow these smaller domain-based team to create a smaller, controlled, purposely built deployment unit, applications and functionalities. And by breaking bigger, complex problems and systems into smaller, controllable unit, we are better be able to adopt the business changes, to be able to push those features capability into production. Also, because the scopes is smaller, we can better control the quality of those application functionalities that we build. We're going to move to the next slide. So the question becomes is how do you make things smaller, right? So what we did is we choose to follow the domain-driven design. And with domain-driven design, start from the business domain that concerns the functionalities, then we'll be able to follow a methodical process to be able to break a bigger complex question into a smaller delicate team and delicate domain to be able to implement and create the bad team more effectively. But by doing that, what we do is we're taking a much bigger application, a much bigger business asking and a business problem, and to break it down to look at that problem, see what are the business domains that need to be involved to tackle that business requirement. And for each of these business domains, we define the clear boundaries, which are today we define them by APIs and the messaging exchanges, right? We strictly enforce that between the domains. That's the only mechanism you can interact with each other, right? There's no more cross the database boundary, doing join queries at the data level. That allows to create those loosely coupled domains. And each of these domains, we assign domain expert. And the domain expert, including a product owner and the service owner. Sometimes some of the domains have delegated the resources from a developer perspective because those domains have much longer and a much complex functionality, much longer timelines. Some of domain may only have the product domain owner and the service owner that with a supplement to the teams whenever that domain needs to be changed. The responsibility of the domain owner is to be the domain expert, to be the expert of the domain from functionality, from scope, from capability perspective. That domain owner is sort of like the product manager of that domain. He maintains the timelines, the roadmap, the future visions, and all of that for that domain. And the service owner essentially is the technical counterpart of that domain owner. He's responsible for the architecture, development, delivery of that domain. And he's a technical expert in that domain with all the technologies and capabilities that domain encompasses. Within VMware's technology standards, the technology service owner and domain owner are free to choose their technology stacks, their architectures, as long as they follow the predefined VMware architecture standards. They are fully responsible for the evolutions of that domain. And the benefit of that is you have a more continuous evolutions, continuous progressions of the domains, allow you to be able to refine capabilities, functionality in an iterative fashion over a long time, versus your traditional development model where everybody come together to do a project. Once project finishes, everybody goes away. Only the minimum crew that needs to keep the application on involved. And over time, you will see multiple applications being built with duplicate functionalities, duplicabilities across them, right? With that domain approach, you have a much more focused and a progressive approach to eliminate those duplications, also allow you to be able to create a much more robust and much more capable business capability in that domain. Now, we want to move to the next slide. Yeah, so now that we break the problem down into a smaller, manageable domain features and domain capabilities, obviously we can no longer building the application the same way we have built it before, right? In the old days, before we start on this journey, applications are being defined by the technology layers, right? You have data layer, you have messaging layer, you have application layer, you have web layer. Each of these layers have expertise and have teams, right? And they all come together to this project. This approach has worked fairly well in the industry for years, but the problem with that approach is, like I mentioned in the previous slide, that you don't have this progression-based, iterative-based change capabilities into these technology domains. And every team are focused on just their layer of the technologies rather than the business. So over time, more and more capability being added to that stack, everything being intermingled. As the time goes by, they become bigger and heavier, and the change to them become more difficult. Right. So what we have done is we are basically taking the domain approach, breaking this application down into vertical slides that focus on the business domains. Exactly what that business needs will drive what that application technology and the stack will go. And each of these business domain team have full control over the stack end to end. Right? They're responsible not just for the technical business outcome of that domain, they're also responsible for the technical outcome of that domain. So there's no longer a pointing fingers and share responsibilities. The roles and responsibilities are very clear defined, and everybody can make a decision with their specific domain. So you have a very good accountability in this new architecture that is business centric and are driven purely by business and they're accountable to the business. As we go through this process of breaking down the monolith multi-tiered application into this vertically integrated business domain-driven applications, obviously your application count is going to explode, right? You're going to go from a singular stack monolith application to sometimes handful, even 10, sometimes even hundreds of different microservices and applications, depends on how this domain further break down their capabilities. And with that explosion of application count, the traditional operation model where you have a delicate team for each application that's responsible to run it, operate it, is no longer going to be feasible, just because the sheer number of application instances that's out there, right? So that's where the platform come into play, right? With a right foundation, with the right platform to basically operate and take care of the application, then you can shift your focus to take care of the platform itself, which is much more streamlined. It can be much more streamlined and efficiently done. And essentially let the platform take care of your application, you take care of the platform. That is our new model, right? In our new model, we are being VMware, we're solely rely on VMware's technology to the large extent, and supplement obviously with other technologies and systems that is the gap in VMware's capability that we'll fill. But it's primarily based on the VMware vSphere foundations. On top of that, we deployed the Tanzu application service and lately the Tanzu Kubernetes grid as well. And these are our major platform component, which allow us to be able to expand our platform to multi-cloud, also be able to efficiently take care of application instances by leveraging those technologies. Okay, we want to move to the next slide. So now we have talked about our approach to application re-architecture and also the platform taking care of the applications. Now let's look at a theoretical model of how we go about actually breaking down a traditional monolith application into microservice domain-driven systems, right? So the very first step we do is we're taking a monolith application and analyze what are the business domains that this particular application encompasses, right? Clearly define those domains and what the functionality these domains needs to provide for this application to function as it is today, right? And for each of these domains, what we do is we create domain-based service to fulfill these functionalities outside of the monolith. In a microservice and architecture, that's where you would see the new service on the right-hand block, right? But now that we have this new service building cloud-native microservice architecture and approach, how do we make sure that as we're doing that, we don't disturb the existing functionalities, the existing applications? Because doing this approach is like you maintain the airplane when the airplane is still flying, right? Whatever you do, you have to make sure the application still functions. Just like you do with the airplane, whatever you do, you still have to make sure the airplane still safely fly, right? So what do we do is, once we have the new service created that fulfills the functionality and the features that we need, what do is we go into the monolith, we took out the corresponding features and capabilities in the monolith. And then what we do is we replace the internals of that functionality with the new service, but maintain the interface layer as it is today. And we do that through this thing called glue code. What this glue code essentially is took out the actual concrete implementation of that feature in the monolith and replace it with the call to the cloud native microservices. Essentially, that glue code acts as a proxy, right? So for the rest of the monolith application, it's like nothing has changed, right? All the existing functional call will still work, right? All the existing data will still be there in the database. The only difference is that the implementation of it is no longer the code inside the monolith, rather it's a API outside of the monolith. But we don't just do a carbon copy of the functionalities. We realign the functionality to the domain model, to the domain data structure and domain functionalities. And whenever there is gaps between the existing functionalities in the monolith and the new service, we put that translation layer also in the glue code to maintain the consistency and the continuity of the functionality for the monoliths, right? As we do, and the next step we do is we're separating the UI layer from the application layer. In the old monoliths, your UI layer is very, very closely coupled with the application logic, right? With the JSPs and the serverless and these things, they are very tightly coupled. So in the new world, what we do is take advantage of the modern technology, modern UI capabilities, where we're translating the UI into React, Angular-driven single-page applications, and talking to the backend through APIs, through API gateways. And after that, as time goes by, we're breaking those domains out into service one by one, right? As the service break out, the interface with other service will also change. They will move away from the glue code. They will be adhered to the domain standard of APIs and the domain data models as they are being refactored. Over time, majority of functionality will be breaked out into those services. That's where you can start tackle the most difficult part, which is the breaking the database, right? And break the database is the most difficult part, but it's also the most necessary part to make your transformation complete. Because without breaking the database up, you still have a single dependency across these applications. You still create a channel where tight coupling can be created by creating joins and foreign key dependencies between the domains, right? So breaking the database is very important as well. Here, when we break a database, obviously the question becomes, hey, database is not cheap to run, right? Database is not cheap to license. So breaking database in this way will increase cost and complexity. We are not advocating necessarily you will have to break it down into physical database instances, but at least what you should do is break the domain at the schema level so that they can easily cross-reference each other's data directly at database layer, right? As far as if you want to break them down into discrete database instances or not, I think it depends on the application, depends on, of course, one is the cost, right? And the operation overhead. And second is depends on how much independent you want to achieve from a resiliency, from our operation perspective as well, right? So With that, I'm going to hand off to Manas, our manager for platform, to talk about our actual platform where all these application systems that after refactoring will be run.
Thank you, Eric. Thanks for that. So team, here is a big picture of our modern application platform. There are so many components which are depicted, but I'll try and walk through some of them so you get an idea about what this is all about. So at the heart of this platform are two major run components, which is Tanzu Kubernetes Grid and Tanzu Application Service. This is the runtime for our modern application platform where all the applications actually run. On the right-hand side, you can see the managed stack. This is the stack which we use to manage our platform, the access and everything. We use Tanzu Observability by Wavefront for monitoring our end-to-end stack. We use VRLI, which is vRealize Log Insight for log aggregation of all our platforms and applications. We use vRealize Network Insight to monitor the network traffic and find out any anomalies in that traffic. We use Tanzu Mission Control for provisioning our on-prem as well as public cloud Kubernetes grid deployment. On the build side, we use Spring Cloud Services and VMware CodeStream for building and creating the artifacts and deploying the artifacts. From a container, certified container image side, we use VMware Application Catalog to select the right and secure images which run on this platform. From a self-service perspective, we've created a lot of self-service APIs, which we use to provide the capabilities what various personas need to effectively use this platform. So basically, the platform operator has insights into each of these layers, starting from build section, self-service section, manage section, as well as run section, with deep insights onto the infrastructure on which this modern application platform runs. The core infrastructure of this is based on VMware's vSphere, vSAN, NSX, and some part of it is also deployed on public cloud like AWS and Azure, and of course on VMware Cloud on AWS. This is the basic breakdown of the application. From a customer standpoint, you may be familiar with some of the critical applications which are running on this modern application platform, namely Customer Connect, which is our centralized technical support portal. 21 million customers, VMware's customers, use this portal to log technical SRs with VMware support. And this portal is running on this modern application platform. Apart from that, like you may be familiar with Spring.io, which is Pivotal's, formerly Pivotal's site offering, which provided Spring-related content that is also running on our modern application platform. That's a brief about the application profile. From a persona perspective, if you recall, Mukund talked about the automation and then Eric talked about automation. So automation is the key piece in running this platform offering efficiently. And self-service was another capability what our development team was looking for to enable agility. We've worked diligently to enable self-service on each and every layer for different personas, be it our application support teams or our application development teams, or for that matter, any of the platform teams, to be seamlessly able to access our platform and execute the functions, whatever they need to fulfill their duties. That has been our focus area. On this platform, the things are very controlled, and we know exactly from a platform side how things are going. And the Tanzu Observability Stack provides us visibility in each and every layer so that we have the right visibility and we know how things are going and how things are executing. that's a brief about this modern application platform, what we've built. I'll hand it over to Mehul to talk about some of the DevSecOps part of this and how we are controlling the deployments going on to our modern application platform and how we are auditing all the components which are going into this platform. Over to you, Mehul.
Oh, yeah, 1 minute. I think before we go to Mehul, right? So sorry, Mehul. I think a couple of other things I just want to highlight to others. I'm sorry, and say I think there are other POCs that we are doing which are highlighted into the light gray boxes, right? We are primarily looking at the Tanzu application platform, and then we are looking at various other things like Spring Cloud Gateway, and we are also closely working with Tanzu Labs to further enhance our developer skill sets. And last but not least, at the bottom right hand side, I think Manas has briefly touched upon was about the public cloud. So we and as I mentioned at the beginning of the session, right, we are putting our critical applications into the public cloud so we can increase the availability. Right? So go ahead, Mehul.
Thanks, Manas and Mukund. If you can go one up. So I think we went over what the application architecture or design side, how it sees breaking down the monoliths into microservices. We also went over how the platform is being run. Essentially, the goal that we were driving in order to achieve the agility that Eric was mentioning was also where we give as much control to developers as possible, so that there are other personas which are your admins and all that, where a lot of ticketing and time is spent in managing and chasing the tickets is eliminated. So essentially at platform level, as Manas was mentioning, we have automated the whole process of requesting resources, like say in case of Kubernetes, requesting namespaces and all that. And the same theme is what we have gone ahead and implemented all our DevSecOps processes. So as you can see on the top row, the gray boxes highlight the various stages an application would go through. And in the blue boxes, what we are highlighting are the different activities that happen and the tools that we have used. Again, these are just to give an idea to the attendees on in terms of what tools we are using. I'm sure you guys will have these tools based on your requirements or the apps that you are running, right? So all our feature requests and documentation happen in Confluence, and the user stories are created in Jira, and all the development activities are run through Jira. Once the design is defined, the application design is completed, and the developers start working on the application development, the source code gets developed and committed to GitLab. What we have done is we have implemented pipelines within GitLab as well, so that as the developers commit the code, it will trigger the automated notifications for peer review, and during the merges as well as on commit, it will perform code quality checks. This is what we started with in terms of identifying what is the quality of the code being developed. Over a period of time, what we have done is we have pushed through more and more conditions where better code quality is getting generated, and developers are getting notifications as well. Mukund, if you can go to the next one slide down, and as you can see, we have also added in the purple boxes the security aspects of scanning as well. So along with every commit, when the pipeline fires up, we perform code quality checks as well as static application security scans using an industry standard tool called Coverity. So what happens is, as part of these, if there are any observations that are coming up, in case, say, code quality fails, then the developer is notified and the code is not getting deployed into any of the environments, including development. and the developer will receive a feedback that the code is not meeting certain standards, and he or she would need to work on it. Same is the case with security scans. In case there are any security vulnerabilities are identified, a defect is created in Jira and assigned back to the developer against that user story that the developer has worked. The configuration management is another area which we have tried to automate end-to-end, where a developer is expected to check in configuration only for development environment or create it once, and later on it gets replicated for all subsequent test, pre-production and production environments. Once the application goes into the build, what we use is a Tanzu application catalog. It is now called VMware Application Catalog, which provides us secure images which are up to date with the latest patch set for containers. We use Maven, Gradle, and any other, depending on the technology stack, we use those tools to build our application and then package it along with the dependencies. Once the packaged app is generated, we run the app through open source software scans as well, using a tool called Black Duck Hub. This is another scan from security point of view, where if there are any vulnerabilities or if a developer has packaged in a vulnerable open source software or a third-party library, a notification is sent out along with a defect, which gets assigned to the developer, and it is the responsibility of the developer to fix that. We check in the code and go through the whole cycle. So it's continuous iteration where a developer is getting continuous feedback, and they keep on updating the application. Once a successful build goes through, it will the image, be it in case of Java or apps or a Spring app, a jar or a WAR file or a container image gets pushed into our artifact repository. We use JFrog for deploying JFrog and Harbor for deploying our pushing our applications. And from there, the deploy CD phase starts, where the deployment of application happens through our vRelease platform. Subsequent to the deployment on a specific platform, be it TAS or TKG or on VMs, we execute automated test scripts which are executed through our test automation platform. It's a custom framework that our QA team has created. We also use the same test cases to perform automated penetration testing. We use several open source and licensed tools for performing the penetration testing while the code is being executed. So this also generates or logs defects which get assigned back to the developer to look into. And once the application is deployed, we also have regular scans run through our Carbon Black container security component, where after an application is deployed into an environment, it keeps on scanning and checking if it has developed any vulnerabilities over a period of time. It can happen where an application has been in production for, let's say, a couple of weeks, where at the time of the deployment, there were no major vulnerabilities from open source components. And later on it comes in. So we use Carbon Black to flag those container security and other vulnerabilities at Kubernetes level. And that is what we have implemented for an ongoing feedback on the application. Mukund, we can go to the next phase. This is just to highlight again some of the components. On the right side is what we have talked about, but how we have brought in the security culture or ensuring that the developers are building secure code to begin with, to avoid any rework on the application and eventually increase the agility of the delivery, where we have given developers plugins on the IDs that they use for tools like Coverity, where as they are building the application or they are writing the application code, they get continuous feedback. We have also put in pre-commit hooks. When code gets committed, those hooks will fire scans and ensure that either secrets or credentials are not getting committed into our source code repositories. And we also do at times third-party. There is an ability to perform third-party component scan on a real-time basis. So these are the things that happen as we have shifted, like essentially from the concept of shifting left. Some of these capabilities is what we have done all the way to the development phase, and the rest from pre-build, post-build, and QA staging and post-production. We talked about it. Primarily, the latest addition to this was the post-production container scanning, essentially provided by our Carbon Black product, where we have not only enabled the workload protection at the VM levels, but also container security for Kubernetes workloads. Mukund, we can go to the next slide. So this, and Eric, feel free to chime in here as well. So these are the areas that we covered and what it has allowed us, essentially all three components, the change in the way the architecture patterns or the design patterns we have implemented, the platform that has been put in place, as well as the DevSecOps processes. Essentially, it has allowed us to increase our feature delivery velocity, reduced security issues. Obviously, we have run programs where from time to time we share like top 10 frequently seen security issues with the development teams, and share with them how they can take care of some of those items during the development phase, so that we see less and less of those security issues. And this has eventually increased the developer productivity, because developers are now able to get real-time feedback, as well as they can get their continuous integration and deployment activities happen on demand, right? Whenever they are ready or they commit the code, the developers are able to see the application run in the test environment. This has also allowed us to have more frequent releases. We are at a point where we can have like release anytime a developer wants to push all the way to production. And this has allowed us to also give us improved metrics in terms of all the way from design to delivery. The time has kind of reduced pretty. We have taken aggressive steps to reduce the time taken to deliver a feature. Anything, Eric, you want to add here?
No, I think it's good. Yeah, you
Okay.
covered the most of it.
Mukund, we can go to next slide. These are these two slides. This one and the next one is where we are just highlighting the amount of artifacts and pipelines that we have managed to execute quarter over quarter. And as you can see, the amount of these executions or artifacts also highlight the number of features that are getting deployed. Mukund, if you go to the next slide, this shows the increase of the features that we have managed to deliver quarter over quarter over last almost 3 years. And as you can see, we have almost we are delivering at the pace of 2.5x what we used to deliver in past. Mukund, we can go to the next slide. Okay.
Yeah. Okay. Thank you. Thanks, Mehul. Thanks to Manas as well as Eric. So these slides depict the way in which you can contact us, right? So we have various ways or means and channels or platforms wherein you can reach out to us. You can send an email to us on VMW on VMW, right, at vmware.com. You can go to blogs, right? We have a dedicated channel or space for blogs. We publish all our like VMware and VMware studies and case studies, as well as do's and don'ts into these blogs. Plus, we have a dedicated space into vmware.com, right? And then you can always also reach out on the Twitter account, that is VMW on VMW as well. Okay. Yeah, so that's the end of today's session.